Leetcode 121, best time to buy and sell stock. It's an easy problem and great introduction to greedy approach or greedy algorithms. And oftentimes you would have those easy or medium problems on Leetcode where you have you can very easily see a brute force solution. Yeah, so the problem itself is not complicated. You can formulate a brute force solution which usually involves something like nested loops very easily, but then the whole difficulty comes from how to make it more efficient. And the greedy approach helps not always, but in a lot of those cases. And this is one of those cases where we can go from O(n) squared, which would be the brute force approach, to O(n), which is a linear time complexity with the greedy approach. Yeah, so that's what we'll try to do today. And let's read the description first, and then we will go through both approaches and see how to make it more efficient. You are given an array of prices where price on index I is the price of given stock on the index or on the ith day. Yeah, so each index represents a different day. We have a single stock of some like imaginary stock. Imaginary currency doesn't exist at all. It's just part of our algorithmic problem where we have simply as an input array or list of integers. Yeah, that's all we have. It doesn't represent anything from the reality. And those are, of course, the same stocks, just that the prices vary throughout the indices, yeah, which theoretically they say here that represents different days. Yeah, and of course, we want to maximize our profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Yeah, so we have here complete knowledge about the future, and we want to choose such a day in which the price will be the minimal to buy. Of course, we want to spend as little money as possible for the buying and as much as possible for selling. Yeah, we want to have the highest profit imaginable. Yeah, so the price when we sell has to be the highest possible, and the price when we buy has to be the lowest possible. And we want to return the maximum profit we can achieve from this transaction. If you cannot achieve any profit, return 0. And those are the input prices 7, 1, 5, 3, 6, and 4. And here they say that we can buy on day 2 when the price is 1 and sell on day 5 when the price is 6. Yeah, so here the price is low, price is high, 6 minus 1 is 5. And the second example, in this case, no transactions are done and the max profit is 0. Yeah, because of what? The prices are getting lower instead of higher. So we wouldn't make any profit by buying high and selling low. That doesn't make any sense, but people do it theoretically. Yeah. And let's just copy maybe this example and think about both approaches. So as we said, we can have O(n) squared and O(n) time complexities depending on how smart our implementation will be. And so the brute force uses nested loops, and we have O(n) squared. Simply we compare all the possibilities, all the options, then we get smarter and we use a greedy approach, which we'll explain in a second. Uses a single pass, yeah, so a single loop, and we end up having O(n) time complexity. Yeah, so the first approach would be to use 2 loops. Let's visualize it in such a way that for the first loop we have the green marker, and for the inner loop we'll have the blue marker. And for each green we will check all the other blues. So we will go 1, 2, 3, 4, 5, and so on. If this would have thousands or hundreds of thousands of elements, we would check for a single green all of them, and then we would move it once and check again all the possibilities. And each time we will recompute the profits, and of course we will have a lot of overlaps. Yeah, so each time compute second minus first, and update if better than current max. So that is the easy approach, which is bad. But let's do it first. So the profit let's start from 0, max profit. And then let's do the two loops. So for first price and maybe also indices, I first price in enumerate prices, and then for second price in enumerate prices, but starting from I plus 1. Yeah, so from the next element, the current profit will be second price minus the first price. And if it's better than the max profit, then we update the max profit. And that's it. So we check all the possibilities. I forgot the column. Let's put it here. Sorry. I used enumerate. I could just, I guess, skip it here, but let's leave it like this. But we need to also put the index. Okay, it's taking a long time to run, and time limit exceeded. So we even didn't get all the test cases right since we exceeded the time limit. So now we need the greedy approach to help us and save the day. So in greedy approach, we'll use a single loop, and instead of comparing all the possibilities, we will keep track of the minimum so far and only compare with the minimum. And that's the whole idea about greedy. Greedy is all about minimums and maximums. So that's the whole story. Only compare profit between, or only calculate between the current price and the minimum. That's it. And that small change will make us go from on squared to on, which let's make the minimum using orange square. Yeah, so the first minimum will be here, of course, with the first number, and then we go here. That will be our second minimum, and we'll get the max profit between 1 and 5, it's 4, then 1 and 3, it's 2, then 1 and 6, it's 5, yeah, and so on and so forth. And of course, this is already the final minimum, so we don't update it anymore, but theoretically, it could be ordered in such a way that further elements would have some better minima than the first one that we find. And here we have, we were lucky, we already found it at the second element. And that's it. So let's change it a bit. And the minimum will be first set to infinity. And for the price in prices, minimum is the minimum between the current price and the previous minimum, and the max profit is max between the difference between current price and the minimum and the previous max profit. That's it. Let's run it. Okay, first two cases work correctly. And we beat only 24%. Let's try again. And we are still on this side. So let's try to optimize it a little bit. So only update the minimum if the current price is less than the previous minimum. And else update the max profit. So we would have a little bit less updates. We wouldn't update it each time we enter the loop, just when the condition is met, which should make it a little bit faster. And as you can see, now we beat 71%, but probably if you rerun it enough times, you can get up to 80 or 90%.